Hey guys, welcome to my channel. Today I want to share with you a spreadsheet that I developed for designing simple rectangular concrete beams. With this spreadsheet you can get the amount of reinforcement required in the beam in order to support the applied moment. Keep in mind that this spreadsheet is only designed for simple rectangular beams that have single layer of reinforcement. This spreadsheet is designed according to CSA 823.3-14, which is Canadian code for design of concrete structures. So let's get into it. Here we want to design a rectangular beam with tension steel only. The main design objective here is to determine the required beam reinforcement such that a beam is able to carry given factored moment. This spreadsheet has three parts. First part is the top left rectangle. Here we have a figure that shows a typical cross-section of a rectangular beam and an equivalent rectangular stress distribution. Here I'm assuming that you guys know what this figure is showing. I'm not going to explain more about it, but feel free to leave a comment and let me know if you want me to make a video and explain more about this figure. Below the figure we have two formula to calculate tension and compression force in the beam. The internal bending moment developed at any location within the beam is resisted by tension and compression force separated by a lever arm. Putting these two forces equal to each other, we can get the value of A, which is the depth of compression block. And using the next equation, we can calculate the moment resistance of this beam. The second part of this spreadsheet is the top right rectangle. Here we have to input the specified compressive strength of concrete, the specified yield strength of the reinforcement, B, which is the width of compression face of the member, and here is the width of our rectangular beam, H, which is depth of our beam, and CC, which is required clear cover to the reinforcement. Keep in mind that you only should change the cells that have red text in them and nothing else should be changed. In the third and last part of this spreadsheet, by rearranging the equation that we had in the first part and using the input that we had in the second part, we can calculate the amount of reinforcement required to resist the applied moment. Here, first you have to type in the value of factored applied moment and then select the reinforcement size that you want to use in this beam. After that, the value of D, which is the distance from extreme compression fiber to centroid of tension reinforcement, is calculated automatically. After that, you can see the result, which is AS, and that is the required reinforcement area. Then the spreadsheet compares this value with minimum required area of reinforcement and shows the final number of the bars based on highest value from the three equations. Last thing to mention is that the maximum amount of reinforcement should also be checked to make sure that the beam is not over-reinforced and the failure is not brittle. Shear and torsion effect and anchorage requirement needs to be checked before strength requirement design is complete. A sound design also takes into account other requirements including bar spacing and deflection. This spreadsheet objective was only to determine the required tension reinforcement in the beam, subjected to given applied moment. However, it can be further expanded to consider all the things that I just mentioned. Alright guys, thank you for watching this video, and if you have any question, you can ask me in the comment section. Also, if you want this spreadsheet, leave a comment and I can email it to you. See you guys in the next video, and thank you for watching again.